Welcome to the TEAM01 Sprint number 3 presentation for Intro to Health Informatics in fall of 2020. The following is our update for the Ventilator Weaning Recommendation System project. The team members as part of TEAM01 include Stephen Campbell, Mitzi Flagg, Carl Franklin, Micah Halter, Bhupinder Hayer, and Joseph Rayner. The following is an update to the Gantt chart. We have completed week 2's assignment of the project introduction, and as we've ended week 3, the team has completed the initial clinical research. The front-end layouts have finished the design phase. We've also completed some of the back-end modules, including the design of them and some of the initial coding. And the architectural diagram has also been fully updated. I'll go into more detail around the activities completed over the past 2 weeks, along with upcoming activities in week 4 and 5. Stephen focused on investigating the differences in algorithm needed for COVID versus non-COVID patients and providing the associated mapping for fire observations. Mitzi changed her initial scope to focusing on the CDS hook implementation and determining what fields would be needed in the database for storing the algorithm details and audit information, as well as updating the Gantt chart. Carl and Bhupinder both worked on the front-end wireframe designs, specifically creating the patient list and detail screens the team discussed, as well as the CDS hook pop-up. Joseph changed his focus to researching the deployment pipeline that we will use and starting to code some of the initial back-end. Micah also worked with Joseph on some of the initial back-end coding, as well as finishing out the architectural diagram with more detail and standing up a test fire server. As we get into weeks 4 and 5, the team will finish out the clinical research and creating the data strategy. Bhupinder and Carl will finish out the design layouts for the front end and starting to code the front end in React. Joseph and Micah will work together on finishing out the design of the back-end modules, as well as continuing to code the back-end modules as well. I will now hand it off to Bhupinder, who will go into more details around the technical updates.
Thank you, Steve. Hi, everyone. This is Bhupinder here. I will be presenting a technical architecture update and also talk about our deployment pipeline and our mockups that we have been working on for this sprint. As far as the technical architecture goes, that we will be using backend technologies in the form of Java, Spring Boot, and Maven. We will be setting up a happy fire server to store patient data, and we'll be populating the data using Cynthia. And we'll also be using a PostgreSQL server for storing more of the settings, the user information, and also things like the CDS hook processing, whether a doctor has actually acknowledged or ignored an alert for any particular reason. On the front-end side, we'll be using React, JavaScript, HTML5, and CSS. The mockups that we have created so far have been created using the Balsamiq wireframes tool. As far as the Spring Boot goes, it runs locally on the port 8080. React runs locally on port 3000. And our plan is to package the whole application into a single WAR file using Maven. So that's it from the technical architecture side. I'll be moving on to the updated technical architecture diagram that we have for this sprint. As I mentioned on the previous slide, so we will be setting up a happy fire server. So that is the one which will be populated with data with Cynthia. That will be one of our key backend components. We will be using Java as the central data processor section shows over there on this diagram. That is where we will be using Java and Spring to basically create all our backend APIs. And then the front end will be rendered by React into HTML5 and delivered in the form of a web app to the end user. As you see the arrows pointing over there about storing data for reports, that is what we will be using Postgres as a database to store settings and some of the other log and audit stuff that the doctor will be working on as the doctor is actually working through the app. Moving on to the deployment pipeline. So we will be working on the deployment pipeline using the HDAP pipeline that has been shared with us as part of the Piazza Post 387. We're still working on finalizing the finer details around it, how all this will work, but the diagram over here shows the overall architecture for the deployment pipeline. The plan is to build a drone build app from GitHub and package React and Spring into a single WAR file. And as part of the next sprint, we are looking at basically building a hello world using all the technologies that I had highlighted on the previous technical architecture diagram page, basically to build the hello world app and kind of like push it through the whole deployment pipeline to basically make sure that it is feasible and it works that way. Moving on to the wireframe and the front-end mockups, the first key wireframe that we have as part of our application is the dashboard view. This dashboard view is going to provide the doctor a quick snapshot of all the patients. It will show some very key high-level statistics as part of our ventilator weaning recommendation system. Things like, how many patients are on the ventilators, average number of days patients have been on ventilators, what is the weaning success rate, and there will be a grid view, a list view basically on this page, which will show the patients by the patient unit, the patient room, highlighting whether the patient is a COVID patient, what is the ventilator risk score, and what is the ventilator weaning status. These risk scores and weaning statuses will be calculated by the ventilator weaning recommendation algorithm, and Stephen will be talking about that as part of our clinical research update after these mock-up slides. This slide will also provide one to be able to filter by the unit, so that will be a pretty key usable feature over here. The next key page in our wireframe mockups is the patient detail page. This page actually shows you the key detail health indicators about a patient. These health indicators will be color-coded to show whether the health indicator is falling in or outside of a particular range. The medications list will also be shown on this particular page, and another key section on this page will be the CDS hook alerts, and these alerts will allow a doctor to examine what actions need to be taken on those alerts. The next set of mockups we have are the CDS hook alert mockups. These mockups will be shown based on the analysis run by the ventilator weaning recommendation system, and they will be in the form of either an information alert or a suggestion alert, or it could be a smart app alert. And these alerts will be shown in the form of pop-ups. They will have options depending upon the type of the alert, whether to just acknowledge the alert, or the doctor might even be able to override the alert. We will be logging all the actions about these alerts they are processing and when they are shown up on the detail page for a particular patient for further reporting.
The last two slides go into greater detail around the clinical research that has been performed. The ventilator weaning recommendation algorithm will calculate an overall risk score for the patient. There are two algorithms, one for non-COVID patients and one for COVID patients. The risk score will use a 1-point system for each criteria not met, with a risk score of 0 indicating a patient is a candidate for weaning. For the non-COVID patient, as you can see, there are 5 top criteria, with the first criteria being different between regular patients and those that are chronic hypoxia patients. The criteria 6 and 7 are optional criteria that the end user can decide if they want to include in the algorithm, but per clinical research are not always indicative of a patient being ready for weaning. Once the risk score of 0 is met for the overall algorithm, the system will recommend that the physician order a rapid shallow breathing index trial, and if that passes, the patient is then ready for weaning. For a COVID patient, the weaning algorithm is slightly different. It adds a partial pressure of carbon dioxide calculation, as well as making the hemoglobin level and temperature non-optional components. So overall, for a COVID patient, there are 8 criteria that must be met in order to provide a recommendation for weaning. If the risk score is 0, the provider will still be recommended to provide a rapid shallow breathing trial, and if that passes, the patient will be ready for weaning. Thank you again for listening to the Sprint number 3 update for TEAM01 for the ventilator weaning recommendation system.